Hello everyone, we're standing here today at Connecting Green Hydrogen Europe in Madrid. My name is Johann Wiebe from Hydrogen Standard, and this event is organized by Leaders Associates. And with me here today, two lovely folk from Aveva. It's called Rosa Urdaneta and Patxi Sala. I didn't get the last part. What is the last part, Vionet?
Sola.
Sarasola. Patxi Sarasola. Welcome, guys.
Thank you very much.
Thank you, thank you.
Great. Well, great to have you, Aveva. We're going to split this up a little bit. First, we'll talk to you, Patxi, talk a little bit about the general sort of tendencies of the market, some projects involved, and then we'll move a little bit more technical with you, Rosa, right? So maybe you can start off, Patxi, telling us a little bit about Aveva, what the business does, as sort of an introduction.
Okay, all right. So Aveva is an industrial software company. We are, very focused in the green hydrogen market, which is really strategic for us and for the upcoming future. And we see this market as really a holistic one, and we look at it from the entire value chain. Okay, and why that? Because historically we've seen that these many actors that intervene in the chain. They've been working in silos, and they've had all the information and data, separated, and we see really that, the demand in this industry, this value chain, is really for data sharing and collaboration. And that involves, starting from conceptual design all the way, to operations and maintenance. And that is what we foster with our software solutions, really, that all this, digital information is transmitted downwards in the value chain. So everyone, starting from the EPC, to the handover and the operations and maintenance phase, everyone can exploit that information and operate better that plant.
Excellent. Well, thank you for that introduction. Maybe we can talk a little bit first, before we delve into hydrogen, on sort of a little bit the legacy of the business. Obviously, you guys have been doing this for a long time, and not sort of so much in the hydrogen market maybe just yet, but more in sort of other established markets. And what are sort of the key things that you learned there and that you're now trying to sort of bring over to the hydrogen industry?
Yes, indeed. It's been over 5 decades now. Seems a long time for software, but that's what it is. It's a long history and legacy. And really, when you look at the evolution of Aveva throughout the decades, you see that what underlies is really the concept of digital continuity. Being able really, to ensure that that information that is generated can be exploited later in the life cycle of the asset. And we strive really, to provide solutions that can allow that value extraction in the entire life cycle. And as I said, that translates into a portfolio in engineering phase or CapEx phase of the projects, during the handover, and also in the OpEx phase. And we've done this, historically. Very strong markets for us are oil and gas, obviously, and power generations. And eventually that has diversified to over 10 verticals as of today. Yeah.
So plenty happening in the business then, I hear. Great to know. So let's delve a little bit into maybe hydrogen and sort of like your view on the market and sort of like the contribution of Aveva in terms of the developments.
Okay, what we do offer is a software solution that really enables these actors in the value chain to better design and build the plants. Okay, that is essential, because the many of the investment decisions are being taken on the actual initial capex, and that can turn the project down. So that is a very important point. And then for those projects that are jumping into the operations phase and into the optimization of the operation phase, then we provide solutions that can really help optimize the LCOH, the levelized cost of hydrogen, which is really, the key parameter that everyone is looking at these days. Yeah.
Okay. Excellent. So you talk about projects. Can you tell a little bit about the projects that you have in your portfolio?
Yes, indeed. And actually, as I mentioned, we have a varied set of customers, and that covers anywhere from EPC firms and engineering firms, okay, with which we are very focused on the simulation, both the power and the process simulation, okay, in order to define the best design of the plant, and Rosa will elaborate more on that. When we look at OEM, the manufacturers of the electrolyzers, We do provide them also with a solution that they can customize, they can incorporate their own intellectual property and develop faster and more efficiently their own new electrolyzers, which is, a very challenging market. Everyone has to develop, with a given set of electricity, more hydrogen output at less cost, and it's a race. So yeah, that is an interesting market in itself. And then of course the owner operators, and what they are asking us for is to be able to provide an entire solution that involves, going all the way from process automation, energy management systems, intelligent software on top of that. And the good thing at Aveva, being also wholly owned by Schneider, is that the combination of both, we can really provide, that single vendor experience, and that also helps, in the projects to develop faster, and having a single interlocution, being able to discuss everything with a single entity in front of you helps a lot, to speed up projects.
So the technical side, power obviously is incredibly important for servicing any sort of application, and that's not any different with the electrolyzers. Power comes from renewables quite often, at least that's what we want to go through if we're looking at the green hydrogen route. And but renewables tend to be intermittent or variable, having an implication on cost. We'll talk about wind, solar, hydro, that sort of stuff. Can you tell us a little bit about that?
Yeah. There is definitely a direct relationship between the intermittence of the power supply and the cost and the hydrogen facilities. And if you would be the responsible for the conceptual design, the first task you have to do is to decouple such intermittence from the hydrogen, the final hydrogen supply. And a second important task is to identify the best design alternative. So to be able to do that, you need a calculation tool or a simulation tool capable to represent that intermittence and to put that into your calculations in order to determine what should be the best installed capacity for the electrolyzers, how much storage do you need for this energy, could be in both areas, so as electricity in batteries or as compressed hydrogen. So with all these factors, these are three key factors to looking for minimizing the levelized cost of hydrogen.
It's the holy grail, minimizing the levelized cost of hydrogen, obviously widely discussed. You can do this in various ways, I guess. Those calculations you referred to, back of the fact pack or sort of Excel, but these days we live in 2024, and there are much more modernized ways in doing so, such as developing a sophisticated software system, as you have. Tell us a little bit about the sort of the unique selling points of that solution.
Mm-hmm, yeah, at Aveva we offer what we call a next generation simulation platform. As process engineer, you usually need to carry out three types of calculations. The first one is a steady state, to develop the heat and material balances of your facility. The second one is hydraulics, to validate distribution networks. And the third one is the dynamic simulation that will allow you to validate control strategies, and for hydrogen to be able to represent this intermittence in the power availability. So those are important because this way you should be able to represent from time zero what would happen with your process and be able to identify an attractive design alternative. This tool also is very transparent, so it will allow you to look at the mathematical correlations involved in the calculations so that you have also an easy way to do customization, and this is basically unique in the market, so that you can very quickly as user introduce emerging technologies. So you don't need to wait for development from our side to implement your new developments on new technologies like in this sector. And the third one is also the capability the tool has to connect with other data, with all the engineering information and also operations information, so that you can develop your digital twin that we mentioned earlier from time zero, using as, let's say, as basis, as platform, the simulation that you start to develop at the beginning and through the complete life cycle of projects.
Okay, there's a lot of technical information and detail in there. I think I understand like the majority of it, but I'll have a follow-up question, and that will test if I actually did. So if I understand it correctly, so the two of the key features are the flexibility to do some sort of scenario analysis to tweak with the variables and see what the outcome is. And the second one is also you provide complete transparency in terms of how you derive sort of these calculations, what sort of like assumptions, because I assume that there's quite some assumptions in there are used, and allow also for the client to make adjustments to those assumptions if that is required for their specific project.
Right. So we are now playing in a new area. There is a lot of development in terms of electrolyzers, for example, but also on the electrical side, on the process side. So you need as an emerging technology, as an engineering company, as an owner operator, to implement those new information inside your calculations tools to predict what would happen to your design or even later on to the operations, and ensure all the time that your hydrogen, the produced hydrogen, has the cost expected in the market.
And the software particularly obviously has a lot of benefits, but it helps towards like making more visible and more transparent in to what degree a project is viable or what the key challenges are in terms of eventually also getting to that final investment decision stage, correct?
Right, because you later on, once you have available and identify the best design alternative in the simulation tool, you are capable to transfer this information along the different engineering phases, not to further develop your projects and to do a more, let's say, agile execution of your engineering projects.
So if I can summarize it up, finally then it's sort of like with your tool you'll be able to do more for less, or achieve more for less.
The more agile, well, yes.
More for less and the more agile work. I couldn't have said it better. Rosa, fantastic. Patxi, thank you so much for having us.
Okay, thank you.
Thank you very much.